Hello and welcome back to Statistics 1. This is the last section of Chapter 8. We're going to talk about one population, confidence interval for one population mean when population standard deviation sigma is unknown. There we go. So what have we done so far? So far we did the confidence interval where we said that we are alpha confident. I see this is purple, I'm not changing it. Alpha confident that mu is in, and then we have x bar minus z alpha over 2 sigma divided by square root of n, comma, x bar plus z alpha over 2 sigma divided by square root of n. So that was the confidence interval. And as you can see, our confidence interval there depended on z alpha over 2, which is a statistic that is related to population. You need mean and standard deviation to calculate z. And then also sigma is in a formula, and sigma is population standard deviation. So we were not too happy, right, with this calculation, because we need something that depends entirely on sample that we have. So no population parameters whatsoever. And we do have that, which is called T-score. So now, T-score is defined as T equals to x bar minus mu divided by s divided by square root of n. Now, before you scream, hold on, there is mu in there, that thing, and mu is population, we actually are trying to solve for mu. So if you take this equation and you solve it for mu, just a simple algebraic manipulation where you get that t times s over square root of n is equal to x bar minus mu, and then you swap the sides, so you ship mu to the right, and you ship the minus t s over square root of n to the right, you can immediately see that you can create, because look guys, doesn't this look the same? You have z-score, you have t-score, you have standard deviation, you have a sample standard deviation now. Looks the same, right? So I can create a confidence interval which will look like x bar minus t s over root n, comma, x bar plus t s over root n. And that confidence interval looks exactly the same as the one before, except now in your calculation all you have is the sample statistic. Now look at this. This also should say alpha over 2 and alpha over 2, because we have to take the half of our confidence interval to each side. So we are focusing on calculating confidence interval for population mean, now using sample only. The last class, at the end, we learned a way to read the T-score chart, which was different than the Z-score chart. And now we're going to first review that briefly, and then jump into a few problems, and we can start chapter 9. So at the end of the book, tables, and the first table that we see is our Tscore table. Now, For the T-score table, as you can see now, for the T-score table, you have this DF business. DF was what? Very good. Degree of freedom. And that DF was equal to n minus 1. N is the sample size that has been sample size since day 1 in this class, 3 months ago. So DF is called the degree of freedom, and it's equal to n minus 1. Now, if you look on the top, you only have certain T-scores that you can get. And those T-scores are T of 0.01, T of 0.1, that's 10%. Then you have T of 0.05, that's 5%. And then 2.5%, T of 0.025, T of 0.01, that's 1. And finally, 0.5% T, 0.005. So what's important before we go and look at any of the values, when you are dealing with these things, you have a two-tail calculation in here, just like you had two-tail calculation for the Z. That is why it's T alpha over 2. So alpha is your confidence level, and that's some percentage. You are 90%, example, 90% confident means alpha equals to 90. Sorry, alpha equals to 0.90. There we go. Which means that you will be looking for the 5%. Because if your confidence is 90, that means that the part in the middle is 90%, and each one of the tails is 5%. So you will be looking for the value T for 0.05. 0.5 is 50. 0.05 is 5%. If you are looking for the confidence level of, so if alpha is equal to 99%, then you will be looking for T of 0.005, because 0.005 plus 0.005 is 0.01, which is 1%, plus 99 is 100. So you have to be very careful. So it's not just what the level you get, it's also the sample size, so that you can use the DF to get into appropriate row for that thing. So now, if your confidence level is 99%, that is asking you to find the T-score of 0.005, and let's say that your N is, 24. Well, if N is 24, that means that your degree of freedom is 23. So you have to go to the row that is DF23, and you have to go to the column for 0.05. So my row with 23 is right, 0.005 is the last column, and then my row for 23 is right here. So the last number is 2.807. So 2.807, and that would be our T-score. and then you will use that in your calculation. So let's take a look at the problem. In the section, we're going into the part 4, Inferential Statistics, Chapter 8, 8.3, and we go to word problems. So that's it, guys. There is nothing else. Not sure why it's blue, but it's blue. Have to go? All right. There we go. Sleep. 8.131. So they give you 10 data points. And they want you to obtain the 95% confidence interval for additional sleep that can be obtained on average for the people using, there are 2 words there that are medical, okay? So 2 medical words. So the data is given to you, but they also gave you what the X bar and standard deviation are, so you actually don't have to look for these. Right? So they give you the data of 1.9, 0.8, 1.1, 0.1, negative 0.1, this means take away sleep, 4.4, 5.5, 1.6, 4.6, and 3.4. So this is the sample of 10 times, right, in hours, and they tell you that this data is giving you X bar as 2.33 hours and standard deviation S as 2.002. Not sure why it has to be dragged out to 17th decimal, but it is what it is. They want a 95% confidence interval. Great. We draw the distribution. We put 95% in the middle, which means that the leftover 2 tails leftover are 2.5% each. 2.5% each. Well, 2.5% is going to look for the t of 0.025. So that's the first part. The second part is that you have 10 data points. So from the top, n equals to 10, which gives us degree of freedom to be what? 9. Very good. So in my chart, I have to go into row 9 and then t-score for 2.5%. Okay, so now if I go to the chart, 2.262, very good. .262. So these two together tell me that the t-score is equal to 2.262. So now, when I go back to my, right here. So that's my T alpha over 2. So now, I calculate the rest. X bar minus T alpha over 2, S divided by square root of n, comma, X bar plus T alpha over 2, S over square root of n. This is my confidence interval in terms of the formula. I have my X bar, that's 2.33 plus minus 2.262. S is 2.002 divided by the square root of 10, comma, the same thing with the plus. Now you take your abacus and you calculate this. Now, the problem said, when you compute these numbers, you should get this. You might be a decimal up or down depending on your rounding. The problem says, construct and interpret the 95% confidence interval, blah, blah, blah. So here is that sentence answer which brings you points on the exam. I usually write answer and then I write it, right? I am 95% confident that the population mean mu is or lies between 0.898 and 3.762 hours. You are allowed to be more specific in terms of saying that the mean of and then say what the variable is all about, which was number of additional hours of sleep for people, and then those two medical words that they have over there. I think they both start with age. I can't pronounce that stuff, which is why I do math. Otherwise, I do anatomy and physiology or something. One more? Or this was good enough? One more, exactly. Let's see another one. So that one was on sleep, inferential statistics, 8.3. Let's see what we can. Family fun. Chips ahoy! 1,000 chip challenge. I should be. Yeah. And at a good rate, may I add. Yeah, it's amazing. It's really, look at that. 0 drop frames. Nice. Okay, chips ahoy. Let's see what else. Military loans, sponsor to jeans, big bucks, shoes. I don't know. Commute times to work. Okay, we have to do this problem because this is just, there's no reality in this whatsoever. 129. Commute times. Oh, northeast commutes. Oh, well, that explains it. It's not New Jersey. Like 24 minutes? Who commutes 24 minutes anywhere? In New Jersey. California, it's even worse. You wait 2 hours on a ramp to get to a highway that is not moving. So, yeah, that's California. But it's nice weather. Yeah. Well, you have other qualities to California, like wildfires and.
The minimum wage is 15.
Which is, of course.
Yeah.
Wow.